Hi, in this video, I will be showing you problem number 13 of chapter 11, section 6. Use the ratio test to determine whether the series is convergent or divergent. Sigma, n varying from 1 through infinity, 10 to the power of n divided by n plus 1 times 8 to the power 2n plus 1. The problem says we need to do this one by the ratio test. So what is the ratio test? If limit is n approaching infinity, absolute an plus 1 over an equal to L, and if L is less than 1, this is absolute value of an plus 1 over an means the ratio of the n plus first term over the nth term. Is less than 1, then the series sigma an is absolutely convergent. But absolute convergence means convergence, and therefore it is convergent. If limit is n approaching infinity, absolute an plus 1 over an is L, but L is more than 1, then the series is divergent. If limit is n approaching infinity, absolute an plus 1 over an equal to L, and that L is equal to 1, the limit value is equal to 1, then the test is inconclusive. So nothing definite can be said about the convergence or divergence of the series. So the given series is sigma 10 to the power n over n plus 1, 8 to the power 2n plus 1, and this expression in blue is a sub n, or the nth term of the series. So now we are going to consider the ratio in the ratio test, which is limit is n approaching infinity, a sub n plus 1 over an. So we are going to find out limit is n approaching infinity, absolute an plus 1 over an, which is limit is n approaching infinity. In order to find out a sub n plus 1, we are going to take the expression in blue and then change wherever n is, that's actually change the n to n plus 1. N alone gets replaced by n plus 1 in this expression. So it is 10 to the power n plus 1, n gets replaced by n plus 1, so n plus 1 plus 1, then 8 to the exponent 2 times n plus 1 plus 1. So put that n plus 1 in parentheses, so be careful here when you find out a sub n plus 1. And then denominator is an, so it is simply the expression given in the problem, which is 10 to the power of n over n plus 1 times 8 to the power 2n plus 1. Then we are going to simplify this, which is limit n approaching infinity. So here again we are dividing a fraction by a fraction, so the second fraction, the denominator fraction, gets flipped and multiplied. So it is 10 to the power n plus 1 divided by n plus 1 plus 1, so that will be n plus 2, 8 to the power 2n plus 2, distribute the 2 plus 1, so it is 2n plus 3. Then we are multiplying, flipping the denominator, so it is n plus 1 times 8 to the power 2n plus 1 divided by 10 to the power of n. Now all that we need to do is to simplify this algebra over here. So 10 to the power n, it's 10 to the power n plus 1, which will give us just 10. Then 8 to the power 2n plus 3, then 8 to the power 2n plus 1. So that will give us 8 square below. So we will have limit n approaching infinity of the numerator 10, denominator in number it is 10 square or 16, then we are left with just n plus 1 over n plus 2. So the number can be pulled out of the limit, which is 10 over 16, which can be reduced. There's n plus 1 over n plus 2, because we are taking the limit. If you divide the numerator and the denominator by n, so it will be n over n, which is 1, 1 over n, which is 1 over n here, then n over n, which is 1, plus 2 over n. The idea of writing it this way, and then we notice 1 over n will tend to 0, 2 over n will also tend to 0 as n approaching infinity. So the limit is, so the whole part of this when in the absolute sign approaches 1. So it's 10 over 16. So when you reduce that, it is it's 8 square is actually not 16, it's going to be 64. So when you reduce that, it will become 5 over 32. Then this part in the absolute sign is simply 1. But 5 over 32 is a number smaller than 1. So in the ratio test, we are actually looking at this part, L less than 1. That concludes that sigma an is absolutely convergent, and all the terms here are positive, so absolute convergence would mean convergence. So here our conclusion is from the ratio test. So by the ratio test, we conclude that sigma, the given series, sigma an, which is 10 to the power n over n plus 1 times 8 to the power 2n plus 1 is absolutely convergent, but absolute convergence would imply convergence. Therefore, the series, given series, 10 to the n over n plus 1 times a to the exponent 2n plus 1 is convergent. So anytime you do factorial related problem or something like a ratio like this, you will be using ratio test. So whenever you do the ratio test, state the requirements of the test, what the test says, and then arrive at one of the 3 conditions given in the test. If it turns out to be condition 3, you have to apply some other test in order to arrive at the conclusion about the convergence or divergence. If it is, the limit is either less than 1 or more than 1, your conclusion would be as stated in the test. So in this case, we proved that the limit is less than 1. So it turns out to be less than 1 here. So the series is absolutely convergent and therefore convergent. Hope this video